Right, we're looking at energy and food content. Um, it's the experiment that I'm actually interested in. It's the next question, but we'll get this one done anyway. Suggest the health problems that might develop if children have too much fat in their diet. Okay, what are the three carb molecules? Oh, what are the three molecules we're interested in? Carbohydrates, yeah, lipids, and protein. Protein. What do carbs break down into? Oh, okay. The one that we're interested in, starch, it breaks down into maltose and then onto becoming glucose. Lipids, you've got two with lipids. You've got what? You've got glycerol and something called a fatty acid. Right. Proteins break down into peptides and then onto amino acids. All these, just keep repeating them so they're going. Right, okay, suggest health problems that might develop if you've got too much fat. Right, the most obvious one that they're looking for is obesity, where you become seriously overweight, which can lead to two things, yeah. Which leads to diabetes and coronary or heart disease. Coronary heart disease. Heart disease. Right, it can also lead to, you can end up blocks up arteries, and it can lead to strokes as well. So you've got heart attacks, strokes, and obesity. Right, okay. And now, do you know obesity also has a side effect of causing excess damage to joints, because you're carrying extra weight about. So you might be carrying extra 20, 30 kilos, and every time you step or move, it's affecting your joints. Right, let's look at F. We're looking at, where are we? Yeah, okay. There you go. Oh, not you. Right, describe how you would carry out an experiment to find the energy value of a crisp, potato crisp. 4 marks. Right, first of all, weigh the crisp. I'm going to send them spelling it crisp. Weigh the crisp on a weighing scale or a balance. Then what you do is you put the crisp on a I think they call it a mounting needle, if you can. You set the crisp alight and put it under. So do you know what I need to do? Right, let's get rid of this. Let's try to put some order to it so then it sinks into our brains in the right order. Right, so next thing you do is measure out, I don't know, 20 mil, 20 centimeter cubed. Measure out, just say 20 millimeter cubed or 20 milliliter. No, not millimeter cubed. That's nothing. Whoa, whoa. Hold your horses. There you go. Centimeter cubed or 20 mil of water into and measure it out into a test tube. Test tube. Right. Then what you do, is measure the temperature of the water before the experiment. Yeah. So what you could do really is pour the water out and leave it in the room for a bit. Let it reach the ambient temperature. Now, what you do is what we'll do is first of all we'll mount the crisp onto a needle and light it. Place under the water if it goes out, relight and place under water again. Place under water to heat the water. Repeat until crisp fully burnt and crisp fully burnt. Then what you do is you measure the temperature of water, and you've got all the details. And then what happens is from here, that's all they want, equals MC or Q equals MC delta T. I think there's different versions of this. That is the mass. That is the specific heat capacity of water, because we're using water. And that is the change in temperature. Change in temperature of the water. So you measure that at the beginning, you're given that, or you look that up. Well, you're given that, and you measure the before and after temperature, and you get the amount of energy yeah, how much energy that particular mass of crisp gave, and then I suppose you could divide it by the amount of crisp you put in there, the mass of it, to get it per gram. Right, here now look. Here what you've got is you've got a 5 marker. They've given you a set of equipment and then they want you to use it, and it'll be exactly the same as that. Right, first of all, what do? We fill tube with water, measure the temperature before, right, before lighting plant sample. Right, before that, what we can do here is what you could do is you could measure the mass of plant on a balance, right? Then what do you do once you've filled it? What do? Right, okay, what we want to do is here, look, measure the temperature, let's put it here, using a thermometer before lighting the sample. Before lighting the sample, using the Bunsen burner. Right, then what do? You use place right, place what we've done, what it is. Right, I'm not happy with that. Let's write this separate. Because what it does, it keeps everything in check. Right. You've measured the mass, you've done that. Mount the plant sample on the mounted needle. Mounted needle. And set a light. Add the place the lit plant sample underneath the what? Underneath the water and heat water. Right. If it goes out, relight and continue heating water. Heat water until plant sample completely burnt. Then what do? Using thermometer, measure the temperature of water. Right. What do we do next? We calculate the energy content using energy content equals MC delta T. M is the mass of the water. So if you've put in 20 ml, it'll be 20 grams. This specific heat capacity is given to you. And delta T is the change in temperature. So if you started at, just say 25 and it finished at 35, it would be 35 minus 25, which is 10. Right, and then what you always do with any experiment, what do we always do? Repeat above steps, remove any anomalies, and average out the results. And you've got it. Right, okay, that's more than enough. That's what it is. So this is an experiment you have to be familiar with anyway. So they might just say to you, how do you measure the energy content of a sample of, I don't know, peanuts or something? So you've got to put all these in. They might not give you a prompt like they have here. Right, okay, that's fine. That's done.